segments were, a segment was a part of a line. A segment was a portion of a line that's measurable, if you will, if you want to think of it that way. We labeled it segment AB, and we put a little bar over the top. Okay? You don't need to write stuff down right now.
I thought we were going on your math site.
No, I was just showing you where all that was.
Gotcha.
To remind you.
Thank you.
And then when we talk about what things mean, when we talk about this word called congruence, or we'll say congruent. Congruent is kind of a fancy way of saying something is equal in measure, equal in value. So this means equal measure or equal value. We use congruent when we're starting to talk about segments. Two segments are congruent if they have the same length. Same idea like that. So if this was one segment here, and now this is now segment CD. If the measurement of those two were equal, let's say they both measured 11, I don't know, then we could say that segment AB equals segment CD. But really, in essence, what that means when we start putting things together is that we say AB is congruent to CD. And that symbol with the equal and the squiggly, that stands for congruent.
Can we write that?
For what?
You said not to write it.
Oh! I was just showing you what it meant. But yeah, you're going to start to see that more often. I thought I would show you the actual definitions of what some of these things are before we get into it. So you got equal measures, you've got congruencies. So things that are going to be congruent, what happens a lot of times when we start working with diagrams, more and more diagrams, you're going to start to see what we like to use are called tick marks. You might have done this before. One of the things that we do, if you have diagrams, if you're given information, let's say this is W, X, Y, and Z. If I say that WX equals XY, that means they're equal in value, which means that I can say that they are congruent, just a fancier way. When I have a diagram, a lot of times what I do is I put a tick mark. You ever seen that before?
Yeah.
That just means those two parts are the same. If they had two tick marks, the other one had two tick marks. Things like that. We do a lot of this congruency markings as we go along, as we get into triangles and stuff like that. Just sort of a little heads up there. But how do you measure a segment? Ruler. Good. When you start with a ruler, where do you usually start at? 0. So if you start at 0 and you measure it out, it's 7 feet, okay? Now what happens if you're in the middle of something? If this you're saying is 7 feet long, that means you started here at 0 and you went to 7 on your tape measure. Well, what happens if you started at 10 feet and went to 17 feet on your tape measure? Isn't it still 7 feet long? How do you figure that out? Subtract what from what? Yeah. So what we use a lot of times is we use subtraction to measure distance, to measure segment lengths, or we take we take one of them, subtract the small one, and take the absolute value, whatever the measurement is. Remember what absolute value is?
Yeah, it means the same thing basically, right? So like the absolute value of -7 is -7, right?
The what? The absolute value of -7 is how much?
-7.
7. What's the absolute value of 7? 7.
7. Oh, you can use negative.
Correct. Absolute value. Correct. And that's exactly what I was looking for. When you're talking about absolute value is always your distance something is from 7. Or It's just your distance to something is from 0, okay? Your absolute value is always the distance something is from 0. That distance is always positive because can you walk -7 feet? No.
If you try hard
You
enough.
can walk backwards, but don't you still go 7 feet?
My mom told me I can do anything I want.
Well, your mom's wrong. I hate to burst your bubble.
Well.
So we use absolute values to measure distances. This is nothing too crazy. The reason why we say that we use the absolute values is sometimes if you had a number line and your segment happened to be on a number line and it had negative value, like this is at -22 and this is at -36, the distance between those two would be the -22 subtract the 36, and that's, we take our absolute value. Or -36 subtract the -22, take the absolute value. That distance is the same going either direction.
So we're never gonna get it.
No. Even if you dig a hole, are you climbing into a cave? You're just moving in a different direction. The distance that you're moving is still the same. It's still positive. Distances are always positive. You can't take miles off your car in reverse.
So you can never go negative anywhere in the universe. Say you would walk backwards in the count, right?
Because we're in a three-dimensional world. You can go backwards.
Right. So the moon, all right, think of it this way. The moon is what, 200-some-odd-thousand feet away? 200,000 miles away?
Yeah.
So if you're going to go 200,000 miles and you get on the moon, and then you still walk, aren't you still moving?
Yeah, that's what I meant. I said, like, you can never go negative, ever.
There is no measurable negative distance that I'm aware of. Even, I don't know if you get to the black holes or anything like that happens, but you can Google that later. That's another thing. Google. Ladies and gentlemen, Google is your best friend. You know why?
I still use ask.com.
You can't Google anything.
Yeah, you can.
It's restricted on mine.
What?
Yeah, my Google.
What are you Googling is what I
No,
want.
like, no, mine is restricted. I don't know why. I can only Google, like, what's 2 + 2. And that's it.
You might want to have that taken away.
Yeah.
So, what I'm getting at here is, a lot of times when you start looking at math problems, you might not know how to start a math problem or whatnot, but if you type in what you're working on, you're going to find help. You're going to get the information. It's there. I'm not, one of the stories of college, bless you, in college, was that we had to take a theoretical calculus course, which was all proof-based. When we start doing some of our triangle proofs, I'll show you what a calc proof looks like, and it was awful. I don't even know how I passed that class. Actually, I do know. Severino. He helped a lot. He's really smart.
Wait, where do you guys go to?
Yeah.
He told us that already.
No.
If you listen, then you would know.
But what happened was, what would that be now? About 14, 15 years ago, when we were taking these classes, Google was, just starting out really. You could actually type in the start of your proof, and you could find a lot of the information online to help you set up your homework. So Google helped us a lot. Anyway, so one of the things that we worked through as we're getting into this is the segment congruent stuff. We did all this, the distance is this, okay, so we did this, talked about that. Now, let's see if we can figure this out. We can figure out how the length of segment AB is here. I know I'm asking a lot, but I have a feeling that even without having these calculators yet, you might just be able to solve this problem. Like I said, I'm asking a lot, but if I wanted to figure out the length of segment AB, what would it be?
5.1.
4.1.
Oh, rip. Oh, wow. Oh, my God.
You might
Yes.
want to if you're having a problem, guys, if you got that wrong, make sure you bring $15 to get a calculator.
I'm going to need it.
Okay. Now, let me ask you this. Most of you guys did this, and you got 4.1.
Is it 4.1?
Yeah.
I thought he said 5.1.
I did say 5 wrong.
Oh.
isn't this,
Did you just write L?
isn't that the same?
C.
Yeah.
Yes.
It works out to be the exact same thing, but what we did, what most people do, is that you see right away that one of the numbers is larger than the other. When you're measuring length, you just start with the large, subtract the small, and you don't have to deal with the negative values. You don't have to worry about taking absolute value. Whereas if I did it the other way, it still works the same. You just take the absolute value when you're done, okay? So it's not a big deal. This is where things get interesting. When we started to talk about this the other day, we talked about something called collinear. What was collinear?
It's
I think it's just one L.
Yeah.
It's same line, points on the same line.
Yeah.
Collinear is when you have points that are on the same line. Now, when you have collinear points, you can measure the distances between each point and add them together. For example, if I walk from here to here and it's 3 feet, and I walk another 3 feet, how far did I go?
60.
Whoa.
Whoa.
It's crazy how this works. So, what we have then is called segment addition. Segment addition is when you have collinear points the total distance is the sum of the smaller segments. What does sum mean in math? Addition, yeah.
Good job.
So in this case here, I have points A, B, and C. Do they appear to be collinear? Yes, because there's how many lines on the board?
One.
One, and all three of those points are?
On the line.
They're on the same line. It's convenient that it works this way sometimes. So the way that I would write this out is that if I wanted to figure out the overall distance, what's the large segment we see here? What is it made up of? AB and BC. So what I can say then is AC, the whole segment, is the sum of the two smaller segments put together. Okay? And you knew that if I drew a picture and asked you, and I put a 5 here and an 8 here, and I asked you, how far is the whole segment? You would say 13. You would know that it would be 13 because all you do is add those two numbers together. It's the exact same thing, ladies and gentlemen. You've done this tons of times without realizing you've done this. Okay. Now, one thing I want you to see here is take a look at what happens right there.
Adding itself.
Not adding itself, but what's repeated?
B.
Yeah. That middle, I don't want to say a midpoint, but the point B is in between A and C. It's on the same line. Okay. You're going to see a lot of times where things are written out, it'll say points X, Y, and Z are collinear with Y between X and Z. Something like that means just that. Points X, Y, and Z are collinear with Y in between X and Z. It doesn't tell you specifically how far away something is, but you're able to take that verbiage, if you will, and write it out into a segment statement. Really, really easily. Okay? Excuse me. Which also means you can do stuff like this. How much is that?
4.
Why is that?
Because 4 plus 18 is just 22.
That's all it is. It's a one-step algebra problem, isn't it? Okay. We're going to see, what's that? Yeah. You guys have done this one-step, two-step algebra stuff all along. It has never been anything new. What's changing up just ever so slightly is that we're going to add it into geometric terms, if you will. Okay? Yes, sir. Sorry, I got you. That's yawn.
Like, is there something, are you gonna have it like that, then we have to solve it, or can we just use our head?
Well, it depends on how the question is. Bless you. If it's sometimes it'll say just solve for x, y, or it might say solve for x, or it might say, there's a bunch of different ways of writing this out. Sometimes it is that easy.
Yeah, I know, I just.
Don't worry so much. For example, do you need to write this one out? Or could you just solve it? Which is? 15. You don't need to write it out. It has to be 15. One real quick thing, guys. Not everything we draw and put up on the board is drawn to scale, so I don't shoot the messenger. Apparently. But remember, in long form, the segment FH is made up of these other two. Sometimes I'll ask you to write it out. Sometimes I'll ask you to write out your segment addition statement, and that's what that would look like. Okay? That's what that would look like. Now, do I only have to have 3 points? What if I had like 5? Could I still do that? Yeah. I could still do that. You know, I could still do something where... Oh, I'm sorry. Sorry about that.
No, I'm good now.
No, Tori, no.
Yeah, no.
Shh. Guys. All right. If this was a can't I still say that segment AE is made up of AB, BC, CD plus DE?
Yeah.
Works the same way. It works the exact same way. And then next week when we start talking about these in terms of angles, larger angle can be made up of many smaller different angles. It's called angle addition. It works the exact same way. It's called what? Angle addition.
Oh.
Stand up for a second for me. Turn 90 degrees to your left.
He doesn't know what that is.
Turn 90 degrees to your left. Turn 90 degrees to your left. And turn 90 degrees to your left. How many total degrees did you just go?
360.
Can you just add up 4 90s?
Yeah.
Angle addition. Cool. That's all it is. That's all it is. And granted, don't get me wrong, we'll throw algebra in there. Well, you'll have like 2x plus 6 equals something or whatever. But the idea is that it's the same thing. You're just adding value together to get larger value. That's it. Going from point A to point B to point C to point D to point E. You're on a road trip. Hopefully you're going down the same road maybe. If this is 4, 6, 7, and 8, how far is the whole trip? 8? No, 10. Wait.
25, right? I counted with my fingers. 25.
Remember, if I'm asking you how far is what's the length of the whole segment is, oops. The whole segment is made up of all the other little bits put together. Guys. And it's just a matter of putting it together. 4 plus 6 plus 7 plus 8, 25. Okay?
This makes good sense.
Good. One of the other things, well, we'll worry about that when we come to it. We all right on this?
No. Yeah.
Excellent.
Well, we'll let everybody, a couple people finish writing that out. Then let's start throwing a little bit of the actual algebra into this thing. Excuse me. All right. Sometimes It's just an algebra problem. Sometimes it works out to be a regular old boring algebra problem, where you have a segment. You have segment TW, and it's made up of TV and BW.
P-dubs?
And then it asks you to find the segment BW. Well, in order to find segment BW, you have to solve for what? X. Now, does this question say solve for X?
No.
It says find BW. So it's an algebra problem that you have to take one more step with in the end. You have to put it back into the equation to decipher which part you're looking for. Geometry does this all the time. You're going to do real simple, straightforward algebra, nothing fancy, and then it's going to ask you to take that bit of information and find something else. On multiple choice tests, on standardized tests, things like that, these are the type of questions you will see that they will give you what are called distractors. And I'll explain that here in a second. Now, if I wanted to solve for X, what two segments make up TW? TV and BW. So I know that this would be my segment addition statement. Oops. All I have to do now is just fill in the blanks. You know the whole thing is 32. First part is 3x, the second part is x plus 8. That's a two-step algebra problem that you could probably do most of it in your head. What's 4 plus 1? Oh, sorry, what's 3 plus 1? 4. Thank you.
Closed.
And then what do you do?
Divide by 8.
Subtract. Ah, not divide 8. Subtract 8. It's not 26, I'm sorry. What is it? 24. Now what do you do? Divide by 4, and what do you get? And what I was saying a second ago about what we call a distractor, one of the options, if this was a multiple choice test, would be 6. And the reason that would be there is because x is 6, which means yes, you got the right answer. But did you solve the right problem? No, because it asked us to find BW. So what do you do with that 6? Yeah. You substitute back up here, and we get 6 plus 8, otherwise known as 14. And now another thing you can do, which I recommend, substitute in the other side as well, and make sure they both add up to equal 32. So this would be 18. So 18 and 14 is? Yay, we math. Okay? And that's the idea, guys. You want to take a second and just double check your work. I know that the algebra is really, really easy, so it shouldn't be daunting or freaky or scary or anything like that. Just take the extra second. Sir?
How do you find 3x equals 18?
What I did there is that I knew that 3 times 6 was 18, because I substitute back up here also. That's what I did. I think I said it, I just didn't write it down. Okay? Is that what you're going to ask too?
No, I was just going to say 3 times.
Yeah. And that's where I got it. I think I said it, but I just didn't write it. All right? Not too bad, is it?
No, it's easy peasy. Lemon squeezy.
All right, well, let's do the other one. Good, this one says.
Oh,
Do we do this one on our own?
No!
Start
Joking.
asking stupid questions.
It's a joke.
yeah, it's a brain.
15%.
Go ahead. Take a second. Excuse me.
You're excused.
Yes, ma'am. What do you got?
I combine my terms. What's the coefficient of that interest? Welcome back down through.
There you go. Does that make sense?
Yeah.
That's all it was. All right, so trying to find the whole, find the part yz. Well, we know that xy plus the yz has to be the xz. What's that? I don't know. I don't know. So we have 2x plus 3 plus 3x minus 1 is 27. Yo.
Oh my god, did I do it right?
Oh, wait, no, I didn't. Never mind.
You can go either way with it. You can have it on either side of the equal sign, it works out. So what's 2 plus 3? What's 2x and 3x?
5x.
5x. What's 3 minus 1?
2.
How do you undo adding? Subtract. So hopefully you got 5 for x, but it asks you to find what? YZ?
Oh, yeah, I forgot.
Yeah, don't forget that. Remember, it's going to happen all the time. You can find x, go back up top then. What's 3 times 5?
15.
Subtract 1? 14. So you have 3 times 5 minus 1 is 14. Double check yellow real quick because the math is really easy. What's 2 times 5? Plus 3? Is 13 and 14 add up to equal 27? Yay! Notice it only took an extra 5 seconds to double check to make sure you didn't done goof.
Did it right.
So take an extra 5 seconds to make sure you don't done goof. Which means you can do stuff like this. I only have 2 more examples here, guys, and we're running a little short on time. So, in this case here, I'm going to show you. In this case here, it says points P, Q, R, and S are collinear, and it says that PS is 46, PR is 18, and PQ equals QR. Now, whenever I see problems like this that have multiple parts to them, this one is saying you're going to answer 4 questions. I don't even bother looking at these until I draw my diagram and I write down some information. So in my diagram, right away, it tells me that the whole thing, that PS, is 46. So I draw it. From here to here is 46. Am I right with that?
Yes.
After that, it says that PR from here to here is 18. And then it says that PQ equals QR. So that means that these 2 segments are the same, which means they are congruent, which means I can put that in there. Those tick marks then show that both of those 2 measure the exact same amount. Well, if the whole thing is 18, what does each part have to measure? 9. Very good.
Mr. Murphy,
Yes, sir.
is the homework gonna be like way harder than this?
No.
Alright.
Now, if the whole thing is 46, that chunk from PR is 18, what's left over then to find RS? What do? Just subtract. What do you get?
Get on somewhere.
Leave your shoes on, please. 28? You're in the glare, I can't see.
You said 48.
Goofball.
So what was it? 28? So now, if I'm looking at this, I have all the segments that I can figure out, and I haven't even once answered, even looked at one of the questions. What's PQ? What's QR?
9.
What's QS?
Oh, I know this one. 36.
Good job.
And then what's RS? See what I'm saying here, guys, is that by going to the diagram and solving everything you can out of the diagram first, it makes going back to the problems easier. Then you don't have to keep going back and forth between them. Yes, ma'am?
Are we gonna have a problem like this on our homework?
Oh, of course. That's why I'm showing examples.
Whoa.
It's very, I try to give you as many examples as I can so that we can see it. It's just a matter of redrawing and filling through. Yes, sir?
So that would, you suggest that strategy like
Every time.
every time?
Every time. Anytime you have a diagram that has multiple parts to it, where often you know, in like worksheets or on problems in the book, you'll see like extra questions to one picture. You want to always try and put as much information you can on the picture by redrawing it or whatnot before you answer the questions. It's easier. It takes less time. Okay? Because you're doing a lot of the work ahead of it. Okay? Now, the last example I have for you, because you can come back and rewatch it, because I got to get this one done. We're just running out a little bit of time here. This case, there's what?
Numbers already there.
There's just algebraic statements. There's no pictures. So you have, when you read the first statement, it says point B is between A and C on segment AC. So what do you need to do? Draw it. That's it. You can put it however you want. But all I'm saying is that if you're having a hard time visualizing what this means, just draw a quick picture. And then you fill in the blanks. 2x minus 5, 6x, and the whole thing is 27. And now it looks exactly like the problem we did 5 minutes ago, doesn't it? Yeah. You just have to start with the idea that this statement is going to be given to you quite often about what it looks like. Sir?
How did you get 27?
It's given to me right there.
Where?
A through C is 27. A to C, look, 26. I'm going to do 25.
Whoa.
How do you do that?
Exposed. Oh.
Yeah, I thought we were doing 25.
Oh no.
I got a math major.
You're funny. You should listen to me. Do magic tricks.
We're okay? I'll give you guys a couple of these. So, what I have for you guys tonight is on page 12. Okay? It's like 15. They're real fast problems to go through. Okay? Should not take very long. I will suggest that on numbers, it's like 21 through 26, there's 6 questions off of one diagram. Just redraw that diagram and fill in the blanks of the diagram before you answer those questions. If you do that, it all falls into place. It'll take you 2 minutes. I don't think this will take you more than, really honestly, 15 minutes. Really. Okay? Yes, sir? Yeah. Do. You guys all have this down?
No. Is it on your site?
It will be, yes.
Okay, cool.